Okay, so consider here the series k going from 2 to infinity of 5 times 2 to the minus 3k. So just like the last one, initially this may not necessarily look like a geometric series, or it may not be really clear how you're going to do it because of the, we have this non-normal thing. We're used to a ratio to the k, but here there's a 3 involved. But again, since it doesn't start at 0, we need to make adjustments to it anyway. So I'm just going to write out my first few terms. So we start with k equals 2, so that would be 5 times 2 to the minus 3 times 2. So that will actually be 2 to the minus 6th power. Keep going. K equals 3, that would be minus 3 times 3. So we're going to have 5 times 2 to the minus 9th power. Keep going. K equals 4. 3 times 4, that would be 5 times 2 to the minus 12th power, and so on and so on. So we notice that we have a common factor here. Of 5 times 2 to the minus 6th power. So we take that out. That makes that one 1. That would make that 5 times 2 to the minus 3rd plus 5 times 2 to the minus 6th, and so on. And then what do my terms look like now? Well, I have 5 over 2 to the 6th. 2 to the 6th is 64, so 5 over 64 on the outside. And then look at what we have here. That's going to be 1 plus, oh, you know what? I'm sorry. Those 5s are no longer in there. That was a mistake on my part there. I should have kept those 5s in there. Not sure how I wrote those down in there. So 2 to the negative 3rd is just 1/8. 2 to the negative 6th is just 2 to the negative 3rd squared. 1/8 squared, and so on. So we can see now that A is 5 over 64, and the ratio is 1/8. So we can write that as the sum, as k goes from 0 now to infinity, of 5 over 64 times 1 over 8 to the k power. And now that we've expressed it as a geometric series starting at 0, we can just use our formula. A, 5 over 64, divided by 1 minus 1/8. So that's going to be 5 over 64 divided by 7/8. Dividing by 7/8, we would multiply by the reciprocal, 8/7. 8 and 64 will cancel to be 8, and that would leave us with 5 over 56. 5 over 56. And so this one converges to 5 over 56. Now, one last thing I want to point out with these geometric series ideas. Again, this approach that we take, right, for our sum only holds if the ratio is absolute value of the ratio is less than 1. So if you have this one here, the formula doesn't work. Okay, the formula doesn't work. Okay, here A would be 1. This would be 1 plus 2 squared plus 2 cubed, and so on. Right? This thing does not converge. Right? Because the ratio, which is 2 in this case, is not less than 1. Right? So remember the idea here, this formula that we've been using in these examples only applies if r is less than 1. Then it's equal to this. So you do have to keep your eye out. Are you dealing with a situation where the ratio is greater than 1, its absolute value is greater than 1? Then it's going to diverge. It's going to diverge. The whole thing is just going to go to infinity.